So modeling with systems of equations. So in example 9, it costs a particular company $200 to make each computer. It also costs them $12,000 to run the business. So things like rental of their building and paying their employees and other bills. So if these computers are sold for $500 each, answer the following. So we're told to let X be the number of computers that are made and sold by this company. So part A, revenue, is the total money that a company takes in. So we're asked to write revenue as a function of X. So we're going to let R be revenue as a function of X. So revenue depends on the number of computers that are made and sold. Okay, so this is the money that they take in. So this $200 is money they have to pay out in making the computer. And this $12,000 was also what cost to them. Okay, but then they turn around and they sell the computers for $500. So this is money that they take in, and it's $500 per computer. So we need to take $500 times the number of computers to get their total revenue. Now cost is the sum, okay, so an addition, of a fixed cost and their variable cost. So we want to write cost also as a function of X. So the cost to the company to make these computers also depends on how many they make. Now they have a fixed cost, this $12,000, that's just this flat fee of the bills that they have. But then they also have this $200 for making each computer. So that's their variable cost. So that depends on, so this part of our expression over here depends on how many computers they make. So the total cost is this $12,000 plus $200 for every computer that they make. So part C, the break-even point for a company is where revenue equals cost. Okay, so they're going to take in just as much money as they paid out to make things, so their profit would be zero. So we want to find the break-even point using the graphing feature on our calculator. So to find the break-even point, we need to know where revenue equals cost. So we need to solve the following system. So we're going to replace R and C with Y's. So we want to know where revenue equals cost. So we're going to call those both. So this break-even point, we're after this X comma Y. That makes revenue equal cost. So this is 500X. And cost, we get 12,000 plus 200X. So again, we're going to push Y equals on the calculator, and you can scroll up and down and make sure that you clear out any existing equations that are on that screen. And then you're going to enter these two equations that we've written here. Okay, so next to Y1, we're going to type 500X. Remember, you have a key on your calculator that has an X on it. And it looks like this, so you can push that to type an X. And next to Y2, we're going to type 12,000 plus 200, and then again, X. All right, so now we're going to push the window button. And we're not going to use the standard zoom feature. This company we're going to see is going to have to sell a lot more than just 10 products, and so the standard window only runs the X's from -10 to 10. So we're going to enter an X min of 0. Okay, so again, remember X is computers, so this is the number of computers that they sold. We're not going to sell negative computers, so we're going to start our X min at 0. And we're kind of just guessing. Remember the calculator, we need to be able to see the intersection point on screen. So we're going to start with a first guess and see what happens all the way out to 100 computers bought and sold, or made and sold. Okay, so then you're going to push zoom 0 and have your calculator adjust the Y min and Y max to graph the functions. Okay. So now you should be able to see the intersection point on the screen. So you can push second trace 5 for the intersect feature. The calculator is going to ask you a series of 3 questions, which we can just keep hitting enter to get by. So enter, enter, enter. And to get the approximate coordinates for the intersection point. Okay, so we're going to look at kind of a sketch of our graph here. So we're going to have a graph that kind of starts in the origin. That was our revenue graph, where it had this slope of 500 and a y-intercept at 0. But then we had our cost function that had a slope of 200, so not quite as steep. Okay, but it intersected up here at 20,000. And we set, our calculator set the X-min ran from 0 and X-max out here ran to 100. And if we use our intersect feature, we saw that this happened at 40. And oops, this wasn't 20,000. This was only 12,000. But our intersection point here was at 20,000. Okay, so these two graphs intersected here at 40, 20,000. Where if we keep in mind our units, 40 was in computers and the 20,000 was in dollars. Okay, so if they sell less than 40 computers, okay, so let's say they sold like 20 of them. Okay, so here is our cost function on top here, and here is our revenue function on the bottom. So we can see that our cost is bigger than our revenue. So in this case, if they sell less than 40, the amount it took them to make those 40 computers exceeds the amount of money that they would bring in selling them. Okay, no company really wants to be in this particular predicament. Okay, but now if they sell exactly 40, so if they're right here at this point, that point is where the cost and revenue graphs cross. Okay, they are exactly the same. Okay, so here cost So here cost equals revenue. But now if they sell more than 40 computers, so let's say somewhere out here at like 60, now we can see the cost function is below the revenue graph, where the revenue exceeds our cost. So now revenue exceeds cost. So the amount of money that the company brought in is now larger than the amount of money that they had to pay out. Okay, and this is where a company would really like to be. So in this case, they want to make sure that they sell more than 40 computers. Okay, so this is what a company would want. Okay, so knowing where that break-even point is, so they know that they want, again, the number of computers in that case to exceed that value. In the case where they're linear, we're going to see some weird things happen when we have graphs that actually have some curves to them. But in this case, as long as they sell more than 40 computers, okay, their revenue is going to exceed their cost. All right, so let's take a look at another example with some data. So example 10 says to use the data below that relates year of birth and life expectancy to answer the following. And we're going to let T be the number of years since 1980. So that's going to be like our starting year. So here for T, 1980, that will be 0. 1985 is 5 years later, and so on. 10 years later, 15 years later. The year 2000 is 20 years later, and the year 2005 is 25 years later. Okay, so the first thing that you need to do is you're going to have to probably pause this video for a minute while you put the values of T and L1, the women life expectancies in L2, and the ones for the men in L3. So remember, you can push stat and 1 to get into the input screen, and we need to first enter these 3 lists of data. Okay, so you should hit pause until you've got those 3 lists of data entered. So then, to find a linear model for the life expectancy of the females, we're going to use the linear regression feature on the calculator. Okay, so to get that linear regression feature, we're going to hit Stat and arrow over to Calculate, and it's next to button 4. And we want to tell it to use list 1, because that's where our inputs are. The output for women is in L2, and we want it to store that equation next to Y1. Okay, so to type L1, we hit second function 1, and then the comma key is above the 7 key. To type in L2, we're going to hit second function 2, and then again a comma. And now to type Y1 we have to push variables, and then over, right arrow over, and then 1, and then 1. Okay, so that'll type a Y1. And then we're going to push enter. Okay, and so on that output screen, we see Y equals, only we're going to put a hat because we know Y isn't exactly equal to this, but it's approximate. It's our estimate. And if we round off to 4 decimal places, we get 0.1171 times X plus 77.4524. So now we're going to do the same thing with the male data. So we're going to find the linear model for life expectancy for males, also using linear regression. Okay, but in this case, inputs are in L1, the output for males is in L3, and we want to store this equation in Y2. So again, we're going to push stat, right arrow, and 4 to call it the linear regression feature. And then second function 1 to type in L1, comma, second function 3 to type in L3, comma, and then to type a Y2, we're going to hit variables and right arrow over and hit 1 and then choose 2 to pick Y2 and then hit enter. And on that output screen, we see Y equals, but again, we're going to put in hat because it's an estimated value, not an actual value. And our coefficient on X, rounded to 4 decimal places, is 0.2097. And then plus 69.8619. Again, you should be pausing the video in several places here so that you actually follow through the key punches and make sure that you can actually get these two models and the numbers to match. Okay, so once we have these two models, in Part C we're asked to use the intersection feature on our calculator to find when life expectancies will be the same. Okay, so we stored the two equations, so we don't need to type them in next to Y1 and Y2, they're already there. So if we push window, and we're going to set X min to be equal to 0, because that actually represents 1980. And we're going to set X max equal to 100. Okay? And then we're going to push zoom 0 to let the calculator adjust the screen for Y min and Y max. Again, you should be able to see the intersection point on screen, so you can push second trace 5 to pick intersect. And we're going to push enter, enter, enter to get past that series of questions. Okay, so on the output screen, we should see the following ordered pair. So 81.995885, comma, 87.057613. Okay, so now let's think about what these mean in context. So if we round this off, so again, our input was years since 1980. So if we round this to the nearest whole number, this is about 82 years after 1980. Okay. Or we don't typically speak that way, so if we take 1980 and add on 82 years, we get the year 2062. And then the output was the life expectancy in years. So if we round this off to about the 10th place, we get about 87.1 years for life expectancy. So in 2062, we estimate that the life expectancy for males and females will be the same, and we predict it will be around or about 87.1 years.